This is Module 2, Lesson 2. In this lesson, we'll be converting units and solving problems using metric mass measurements. So in this lesson, we're looking at metric mass measurements. Mass is like weight measurements in standard measurements. The two measures we need to be aware of in this discussion are grams, which is signified with a G, and kilograms, which is abbreviated with a kg. And again, to give you something to visualize, a gram is about the weight of a small paper clip. And a kilogram is about the weight of a dictionary. And as with measuring in lengths, we can convert from one unit to another by multiplication. So 1 kilogram is equal to 1,000 grams. So if we want to go from kilograms to grams, we would multiply by 1,000. So 1 kilogram would be 1,000 grams. 6 kilograms would be 6,000 grams. 10 kilograms would be 10,000 grams. And so forth. Let's use this to solve an addition problem. Let's start with 8 kilograms, and we're going to add to it 8,200 grams. And as we noted in our measuring of length, we have two different units, and we can only add numbers together if the units are the same. So for this one thing we could do is turn the 8,200 grams into 8 kilograms and 200 grams. Then we could add the kilograms together and end up with 16 kilograms, 200 grams. We could also turn the 8 kilograms into 8,000 grams and add it to the 8,200 grams and end up with 16,200 grams, which we could simplify into 16 kilograms and 200 grams. Either one of those strategies would work. Let's try another one. Let's say we have 25 kilograms, 537 grams, and we're going to add that to 5 kilograms, 723 grams. Let's look at a couple of standard algorithm solutions. First, we can write it as a vertical problem. We can first add together the grams, and we get 1,260 grams, which we can simplify into 1 kilogram, 260 grams. Then we can add the kilograms, then combine the kilograms into 31 kilograms, 260 grams. That would be one solution. We could also turn both of them into grams and just add. and get 31,260 grams, which again can simplify into 31 kilograms, 260 grams. Either one of those strategies would work as an algorithm strategy. Let's look at a simplifying strategy. We could first add together the 2 kilogram measures. Then we could look at the 2 gram measures. And we could decompose these into 500 grams plus 37 grams and 700 grams plus 23 grams. We could add together this 500 plus the 700 to get 1,200, and we could add the 37 and the 23 to get 60. And when we add these together, we get 1,260 grams, which decomposes into 1 kilogram, 260 grams. And then if we add back in the 30 kilograms that we added together in the beginning, we end up with 31 kilograms, 260 grams. That would be a simplification strategy. Let's also look at this for subtraction. Let's say we have 10 kilograms and we want to subtract 2 kilograms, 250 grams. First, as an algorithm strategy, we could write it vertically. And as we would with any subtraction problem, when there's nothing here to subtract, we would regroup and subtract 1,000 from 250 and get 750 grams. And then we could subtract 9, take away 2, which would be 7. That would be one strategy. The other thing is we could turn all the numbers into grams. And when we subtract, we get 7,750 grams, or 7 kilograms, 750 grams. That would be 2 algorithm strategies. We could also do a simplification strategy. Start by subtracting the kilograms. 10 kilograms minus 2 kilograms would be 8 kilograms. And then we could decompose that 8 kilograms into 7 kilograms and 1,000 kilograms. 1,000 grams, I'm sorry. And then we could subtract the 250 grams and have 750 grams with the 7 kilograms, getting the same answer. So again, whatever strategy works for you is fine as long as you can generate a correct answer. Let's go and do some problems in the problem set. So in number 1, you're going to complete the conversion table. So pause the video for a moment and complete the table. Okay, 1 kilogram is 1,000 grams, so 3 kilograms would be 3,000 grams. 4 kilograms would be 4,000 grams. 17 kilograms would be 17,000 grams. 20 kilograms would be 20,000 grams, and 300 kilograms would be 300,000 grams. For problem number 2, we're converting the mixed units into grams. So pause the video and do A through F. For A, 1 kilogram is 1,000 grams, plus the 500 grams would be 1,500 grams. For B, it would be 3,715 grams. For C, 17,084 grams. For D, 25,090 9 grams. In E, if we had 7,481 grams, we'd have 7 kilograms, 481 grams. And for F, we'd have 210,090 grams. Moving on for A, pause the video and try A. In A, both the units are already in grams, so all we have to do is subtract. So we'd have 2,215 grams. Pause the video and try B. For B, we could turn 1 kilogram into 1,000 grams and subtract 237 grams. And the result would be 765 grams. For C, we have mixed units, and it tells us to answer in the smaller unit. So choose a strategy that works for you and try C. Okay, for this one, we could write the problem vertically. If we add the grams, we get 1,000 grams, which is 1 kilogram. And here we get 49 kilograms plus the 1 kilogram. The answer would be 50 kilograms or 50,000 grams, expressing it in the smaller unit. Pause the video and try D. For this one, let's try the strategy of writing both numbers in grams since we want to end up with grams. So the first number would be 27,650 grams, and we're going to subtract 20,990 grams. And if we do that, we end up with 6,660 grams. And we're leaving it in grams since it's the smaller unit. E tells us to perform the subtraction and then express the answer in mixed units. So pause the video and try that one. So for this one strategy is we could write the first number in grams and subtract it from the second number. And we'd get 10,217. But since we need to write that in mixed units, it would be 10 kilograms and 217 grams. Pause the video and try F. Let's try doing this one as a vertical problem. And we're adding 57 kilograms, 481 grams. If we add the grams together, we get 1,139 grams. We can rewrite this as a kilogram. So we have 62 kilograms plus 1 is 63 kilograms and 139 grams. Okay, moving on. For these problems, we're going to use a tape diagram to model the problem. Choose a strategy that works for you, and then write your answer as a statement. Pause the video and try 4. So here we know that we have one package that weighs 2 kilograms, 485 grams. We have a second package that weighs 5 kilograms, 959 grams, and we want a total. So this type of tape diagram where we have two parts and we want a whole tells us that we need to do addition. So if we write this as a vertical problem, and we first add the grams, the 1,000 becomes a kilogram. So we have 444 grams. We have the 2 plus the 5 is 7, plus the 1 here. We end up with 8 kilograms, 444 grams, which expressed in grams, if you decide to do it that way, it would be 8,444 grams. So the 2 packages weigh 8 kilograms, 444 grams, which is the same as 8,444 grams. Okay, pause the video and try number 5. Okay, here we see that we know the total. The 2 fruits together weigh 6 kilograms, 230 grams. We know the pineapple weighs 1 kilogram, 255 grams. That's the pineapple. And we want to know how much the watermelon weighs. So again, when we have a total and one piece and we want to know the other piece, we know we need to subtract. So let's write both of these numbers in grams. So the total would be 6,230 grams is a total of both fruits. The pineapple weighs 1,255 grams. So if we subtract, we get 4,975 grams. So the watermelon weighs 4,975 grams, which is 4 kilograms, 975 grams. Okay, pause the video and try number 6. Okay, we know that Bradley's dog weighs 24 kilograms, 175 grams. And we know Javier's dog weighs 3,902 grams more than Bradley's dog. And so we're looking for the total of Javier's dog is the question. So when we see 2 parts and we're looking for a whole, we know that's addition. So if we turn both of them into grams, we have the weight of Bradley's dog and the amount more that Javier's dog weighs. And if we add those together, we get 28,077 grams, or 28 kilograms, 77 grams. So Javier's dog weighs 28 kilograms, 77 grams, or 28,077 grams. Okay, pause the video and try number 7. Okay, this table shows the weight of 3 students. How much heavier is Isabel than the lightest student? So we first have to decide whether Irene or Sue is the lightest student. So this one is written in grams. This one is kilograms and grams, but if we rewrite this in all grams, we see it's 29,038 where this is 29,238. So Irene is the lightest student. So if we're looking for Isabel's weight, we know Isabel's weight is 35 kilograms. And we know Irene weighs 29 kilograms, 38 grams. That's Irene. And we want to know how much more the 35 kilograms is from what Irene weighs. So again, this tape diagram tells us that we need to subtract. So if we start with 35,000 grams, Isabel's weight, and we subtract 29,038, which is Irene's weight, the difference would be 5,962 grams, which equals 5 kilograms, 962 grams. So Isabel is 5 kilograms, 962 grams heavier than Irene. And that ends lesson 2.